Hey guys, Bukule here. I'm gonna do a video for you real quick. Hey, we had an earthquake just a few hours ago in Puerto Rico. It was about a 6.3, which is pretty substantial, and it was extremely shallow, like at 10 kilometers. There are no tsunami warnings or nothing like that, so don't think that. And I'll show you guys how to check that here in a second. But here it is right there. Okay, it looks as though it might be on one of those plate boundaries. But I do have some interesting things I want to share with this. But I'm going to show you this first. Okay, right here. There it is, 6.3, 6.3, 6.3, 6.0, 6.0. Now, a lot of people would think, like myself, would basically call that aftershocks. I'm not sure what denotes an aftershock, or if it's a separate earthquake, how they would differentiate between the two. But regardless, there's activity there, earth shaking down there. So, but yeah, I mean, I've seen earthquakes in Puerto Rico and stuff before. I think we all have. But that's a pretty sizable one for that area. I'm not sure. I'm not sure if Dutch was talking about that at all or not. But I would encourage you guys to go over there and check him out because, yeah. But let me show you what's going on with this real quick. Okay, I'm going to pause for a second. Okay, guys, this is NOAA. Okay, you can go there and you can check for tsunami warnings. Okay, this is where you go if anybody ever wanted to understand or wanted to know where to go to look for this. This is where you go. Okay, and it says right there, right away, no tsunami warning, advisory, watch, or threat. And they're talking specifically about this Puerto Rico one. Okay, now you see it right there, so you just click on it, and then you can go to there, and it'll tell you. All right, you click on that link, and it'll basically say the same thing. Okay, so I'll leave a link to that. So if you guys ever want to know if there's a tsunami warning for a particular earthquake, that's how you go check. Okay. Okay, I got you guys over here at one of the sites I used to show you some of the graphs. Well, I told you I was going to show you some stuff, what was interesting about this particular earthquake. Well, if you guys remember yesterday, number one, I said, we should be looking for upticks in earthquakes. Well, all of a sudden, bam, there's some. And it wasn't nothing that everybody else wasn't saying either, because I think a lot of people were saying the same thing. So it's not like I was the only one saying that. That's not my point. My point is that we have reasons for saying things like that, and it was basically the coronal hole, all the extra energy coming this way, phi angle, all those things that I've talked about before. But just know that when we say things like that, at least for me, I don't say like earthquake watch or hey, look for uptick in earthquakes unless I actually think that's what's going to happen. I'm not just going to say that just for whatever reason. There's always reasons behind what I say on that end of it and I usually try to tell you guys that. So, but what I find interesting on this is the electron flux. Okay, over here. I showed you guys that spike right there the other day. Well, there was another small one here, okay, and then right here, right? Now, if you guys understand electricity and how it works at all, at a very basic level, okay, what electricity is an electron moving from one atom to another. It's that flow, okay? So you have three particles on a basic atom level, okay, which is electrons, neutrons, and protons. Okay, you're going to understand those words because there's electron, there's one particle, there's protons. Okay, neutrons are neutral. That's why they're called neutrons. But what an atom is essentially trying to do to be a stable atom, it's trying to have a negative and a positive. Okay, so the electron is negatively charged. Okay, the proton is positively charged. So it tries to have the same equal amount, and there's a lot of other stuff that goes into that. I'm talking about just at a very basic level. Okay, so when we see the proton flux go up or the electron flux go up, we know that we're seeing an uptick in electrons or protons. That's what we're talking about there. They're particles of the atom. All right, So I wanted to explain that, okay? But what's interesting right here, that's a 3-hour increment hash mark here. These little hash marks every 3 hours. That earthquake happened at 3:23, I believe, on the 24th, at the exact time that we had this flux. Okay, I mean, right on it. Not even close. It was at that time. But what I find interesting is that we had this big one here. So what happens, guys, I think, is this does, like I've said before, this isn't the only thing that contributes to us having earthquakes. There are so many factors. All I'm saying is that this is one of those factors. That's it. And when we're talking about those kinds of things, one of those factors will be the straw that breaks the camel's back when it comes to an earthquake popping off. It might not always be this. It's something else. Okay? But this is a factor. That's why I'm pointing this out. Okay? So when we see the electron flux spikes and stuff like that, it adds energy to us. Okay? If it makes it through our atmosphere, our crust absorbs it. Okay, cosmic rays, they scatter when they get in our atmosphere, and they get really deep. They can get deep and add energy to our crust and into the inner parts of the earth, not just our atmosphere. Okay, so that energy has to go somewhere when it builds up so much. Okay, so that's why I think that this has something to do with earthquakes and things like that, because that energy has to be released when the earth can't hold it anymore. And sometimes it gets released in the form of an earthquake or a volcano or, whatever other climatological thing we want to talk about. It all comes down to that. So, anyway, I wanted to show you guys that. I just thought that was really interesting. Okay, guys, got you over at ISWA. Okay. This is what I was showing you yesterday. These are just the updated pictures of the sun, the 193 and the 211. Okay, you're seeing the coronal holes, right? That's getting ready to rotate through. Okay, we're going to get some effects on that. We're going to get some solar wind from it. We're probably already connected to it magnetically. I'm not really sure. But what I want to talk about is this. Okay, that's that coronal hole that we're experiencing now. We're getting some winds off of it now and have been for about a day. Okay. As you can tell, it's pretty much dissipated as it rotated through. Now, we've been talking about this a little bit, and I don't know why this happens, and Scott's been talking about it, and I'm sure there's some science behind it. I'm not sure if we fully understand it yet, but what happens is as it passes and rotates past Earth, it seems as though these things dissipate rather quickly, typically. Okay. Plus, for example, this hole here, when it was over here, was really small. So as it was coming closer, it grew. And guess what? This one here, when it was over here, did the same thing. Okay, and we're seeing that pattern over and over and over again. So we're starting to question what's going on there. All right, that's my point here. But something else that I've noticed. Can you guys see these little dark areas? Okay, those are holes also. The atmosphere is opened up on the sun there. Okay, so there's solar wind coming out of that. All right. Excuse me, sorry. And I talked about the northern and the southern coronal holes that always stay there. Okay, they're always there. Now, I've never seen this happen. I'm not saying it never has happened, but I've personally never seen it. That I've seen some large coronal holes like this before, but I've never ever seen them connect the northern and southern coronal holes to one. Okay, now that ain't what has happened yet. But if you look at this, you can see how that's almost into the northern coronal hole. And if you look down here, it's stretching down here too. Now, what does that mean? Honestly, I don't know. It could just simply mean that is a wider area of solar wind. But I find it really interesting because I've never seen a coronal hole stretch from the north to the southern pole. I've never personally seen it. Now, it could have happened before. I've seen large coronal holes. Don't get me wrong. But again, this is one of the main reasons why we talk about the earthquake risk getting raised. Okay, this is something that happens. Now, that spike we've seen, yeah. I'm going to show you guys something else here real quick. Okay, guys, I got you over here at the Australian Magnetopause model. Now, I'm going to say something else here real quick, too. The Magnetopause models I show you guys usually, the SWMF, that tool there with the, that's got the yellow blues and the reds. I show you the solar wind over there. I show you a whole bunch of different stuff. It's got the lines with the interplanetary magnetic field lines. Those are the graphs I'm talking about. Okay, they're still down. All right, they've been down for a week. Is that coincidence? I don't know, but I do know that LASCO C2 and LASCO C3 are down now also, and have been since the 21st. Now, you can access those two tools on different websites. So how do I know that it's not just the website? Well, because they're not updating on any of the websites. So that's a satellite issue. Okay? Those cameras are on a satellite called SOHO. They sit right out in front of the Earth, pretty close to where SDO is. They're detectors and they take captures, all kinds, basically the same thing that most of the satellites, laboratories, whatever you want to call them, in space do. Okay, like SDO, Stereo A, and then SOHO. SETI, same thing. Okay, those are all different satellites, but they have basically the same tools on them, the same types of cameras, same types of detectors. That's what I'm trying to say. But that's not updating, so there's something going on there. I don't know what it is. Hopefully it gets up quickly, quicker than not. Now, we've seen seeds, because I can't show you guys seeds right now, that black and white. And I do think that at some level they're going to start, if they haven't already started, censoring that one really, really heavily, because we're catching a lot of stuff on that particular tool right now. Okay, we're seeing our Planet X object there where it's supposed to be on time almost every month now. Okay, so when we start doing that, I really look for that thing to start getting censored really, really heavily. But we'll see how it pans out. But this right here, okay, I missed this yesterday, and I'll show you why. This is our magnetic shield that's out in front of us, right? This is the Australian model, just kind of bounces back and forth, and it gives us a capture every minute. Okay, which is very, very, very quick. It's more than what the other tools give us. The other tool I was just talking about, we only get an image every 4 minutes. So we're seeing 4 times the amount of data here. So basically what I'm saying is, though, when I play this, see if you guys can't catch it. See that little boop? Okay, I'm going to play it backwards. See that? All right, so what am I talking about? Well, I know that at 16, or was it 08 or something like that? Okay, what I want you to look at is the protons. 4.5, right? That's pretty normal. Between 1 and 5, even 5 is kind of high for a normal day, okay? But watch what happens. It's really hard to catch unless you slow it down and do this. See that? Okay, that's at 16:17 UTC on the 22nd. That's at 16:18. See how big see how it came in? It almost made it into our satellite line. Now, what I want you to look at here protons. Right there. Now watch. That's at 3.1, and it goes from 3.1 to 138. And then the next capture, which is only a minute later, 59, and then watch this, right back to normal. Okay, so what that was a very, very quick spike, a big burst of protons. Okay, now, you know what caused that? Well, we are getting solar wind, but typically solar wind doesn't have that big burst and then go right back to normal. Okay, not that quick. So most likely this is either our object magnetic field interacting with the sun's magnetic field, like I've talked about before, and sending some energy that way. But even that, this time, is probably not what's going on. It could be, but I think most likely this time it's a cosmic ray because of the quickness and just the big blast. Okay, and plus the electron flux jumped like that. And sometimes when we only see one tool react, a lot of times that is an indication that it's just a cosmic ray. I don't want to say just a cosmic ray, because cosmic rays are bad. All right, they give us a bunch of radiation. They make it through our atmosphere way deeper than what just a typical solar wind will. They add more energy to the crust. Okay, and that's why we talked about the earthquake stuff. But it does give us radiation also. So that's that's one of the risks that we have to take in consideration. All right. So, yeah, with that being said, that's what happened. Okay. So that was on the 22nd. I missed it. And I don't know if anybody else even talked about this, but I just wanted to bring that to you guys real quick. There is going to be a model update here on the end. And again, just pay attention. Keep an eye out on the earthquake stuff. I do think it's going to continue to uptick as these solar winds keep hitting us. We'll keep an eye on those coronal holes, and hopefully we can, come up with something to explain some of the stuff that we're seeing. So, but anyway, God bless. Sheila saves, and you can drink this Kool-Aid.